Welcome here, and we're doing the Cambridge non-calculated practice questions, extended ones. And we're looking at vector questions, and specifically question 13. Right. First thing we're going to do is we're going to go through all the information carefully. O is the origin. That is important. That is going to be relevant later. So all the vectors are starting from O. And OPQR is a parallelogram. Okay, that is also important. Because what do we know about a parallelogram? That opposite sides are parallel and the same length. Now, vectors, if something is parallel and the same length, they are the same vector. Meaning if OR is lowercase a, PQ is also lowercase a. If OP is lowercase b, RQ is also b, because these are opposite sides of a parallelogram. They are the same vector. Right, then it tells me SOP is a straight line. That's important, okay, because that means SO is going to be the same vector because it goes in the same direction as B, and SO equals OP. So that would mean SO is also B. TRQ is a straight line with TR equals RQ. So again, that will also be B. So we've got another parallelogram. We've got actually three parallelograms, two small ones and one big one. Okay, so we can say this is also A. You can see that, even though it says not to scale, there needs to be specific here because it says not to scale. You can't just assume because it looks like it. But with this information, we know what we see is true. Okay, then the last bit. STV, I'm going to change color here. STV, it's this straight line, is in the ratio 2 to 1. Okay, so it means if this is 2, that's 1. This means like if we cut this line into two parts, that is one part of it. Okay, meaning we cut this one in half, this will be a half A, and that will be a half A, and this will be a half A, because the ratio is 2 to 1. Two halves makes a whole. Straight line, the parallel, so this is also the vector half A. Okay. We have now dealt with every piece of information. In the end, it just tells OR is lowercase b, and you can see that. Okay, so every sentence here has a meaning. So we cannot just skim through this and expect to answer the question. Think about what everything means. What does origin mean? What does parallelogram mean? What is the implication of that? So we're moving on to the questions. Find in terms of A and B in the simplest form. That's also important. People always miss this. The position vector. Now, what is a position vector? Again, this is where the word origin comes from. Position vector is the position of a point. That little dog, please stop barking. My goodness. Right, it's the position of a point. Right, little barking dog is gone. So we can go continue. Position vector means of t is where t is in relation to the origin. So if the position vector is where do you start from the origin to get to t. So this is what it means. Position vector of t is from the O to t. Okay. Of course, we don't know what that's in terms of A and B, so we need to follow a path. We do know. We're going to follow this path. Okay. So in reality, you can say OT, that's the position vector from the origin to T, equals the path I know from O to R and R to T. We can do O to S and S to T as well, but I'm choosing this one. So it's OR plus RT. Okay, so the position vector of T, OR is A, and then because we're going in the opposite direction of this vector, this would be negative B. So it's A minus B. Sorted. Next one is RV. Okay, so RV goes from there to there, like so. Okay, let's just clear this now because it's not relevant anymore. Okay, again, we're going to follow a path that we know. So RV is RT plus TV. Let's just write that down. RV is RT plus TV. That's the path we're following. So RT being negative B, and TV, remember we already figured that out before. If the ratio is 2 to 1, then this will be half an A. So TV half an A plus half A. Now that's good, but you'll see in the mark schemes usually they write to put the negatives seconds. But if you write it like this, nothing wrong with it. Minus B plus a half A, same as a half A minus B. Same thing. Okay, last one is to show that PT is parallel to RV. Oh my goodness, what does that mean? PT parallel to RV. Now remember, two vectors are parallel if they got the same vector. For example, we can say SP is parallel, that's a parallel sign, to RQ, for example. They don't have to be exactly the same, because SP will be 2B, because it's B and B, and RQ is just B, but they're parallel because of the B. They can have a different coefficient, yeah? It just says that SP is double the vector of B, but they are still parallel because they got the same vector. So we can prove that the same with PT, was it? PT, yes, PT. Okay, so they want us to say that PT is better. Okay, because it looks like it, but of course, yeah, not to scale means we have to prove it. So let's write down the vector for PT, and again we're going to follow a route that we have B's and A's. We can do P to S and S to T, or we can P to Q and Q to T. We can even do P O O R R T or any of those. Okay, I'm going to follow this route. I'm going to do this and this. So I'm going to say PT is equal to the vector PQ plus QT. Now PQ, of course, that is A. And QT is 2B, but we're going against the vector. We're going the opposite direction, so it's minus. Okay. Now, we need to show that PT and RV are parallel. Look at RV. It's a half A minus B. See, this is almost the same. How can we make this look the same? Well, there's two ways. We could either factorize out here a 2. If you put the 1 there, it means you need to have a half A minus B. See, 2 times a half is 1A, and 2 times minus 2B. Can you see now? We've got exactly the same vectors there. This bit here, and that whole thing there is the same. That means it's parallel. Or we can multiply this vector by 2. So that means 2RV, 2 times a half is A, 2 times 1, 1A, and 2 times minus B is minus 2B. And now they're the same as well. Yeah? Now, I've done this the other way around. PT is A minus 2B, and 2RV is A minus 2B. This last one is maybe better, because it corresponds better with, so you can say, thus, they are parallel because PT is twice RV. Okay, but I believe what I've written here would be enough to prove it. Yeah, they got the same vector, so they are parallel. I hope that makes sense. Look at this, let's look at the mark scheme. Question 13. Question A, first one, A minus B or minus B plus A, just like I said. Second part again, you can have the negative first. Okay. And then here you get a mark for A minus 2B. And then only after you've gotten that, you got a mark for this. Okay. So you don't get this mark if you haven't shown A minus 2B. You can write this in words. You don't have to say it. But I think it's important to show that the one is double the other one. Yeah. So in short, you get a mark for this. And then a mark for showing that it's double. You can say it in words. You can say RV is double PT. So they are parallel. Yeah. You get it. You're going to get it right. Well done. See you later.